All right, today's objective, students will be able to find missing sides using law of cosines. So last week we worked with law of sines to find missing pieces in any triangle. This week we're going to be working with something called law of cosines. So we have new formula, just like with law of sines, where we had three versions of it. We had sine of A over A, sine of B over B, and so on. We've got three different formulas for law of cosines as well, but they're all pretty much the same format. It just depends which piece you're solving for. So if you're trying to solve for angle A or side A, side A or angle A, so side's lowercase, angle's capital, you use the first formula. Side B or angle B, you use the second formula. Side C or angle C, you use the third formula. So let's take a look at an example problem here. So number one, we're trying to find AB. So the first thing I would do, just like with law of sines, is label your sides with your lowercase letters. So we label those sides based on the angle they are opposite from. So opposite of angle C would be side C, opposite of angle B, side B, opposite of angle A, side A. So instead of finding AB based on what we've labeled, we're trying to find lowercase c. So if we look back to our equations, since we're trying to find lowercase c, we're going to use that third equation. So from there, it's pretty much just plugging in and then using your calculator. So c squared, little c squared, equals little a squared plus little b squared minus 2 times little a times little b times the cosine of big C or angle C, 109. So notice our variable is pretty much already isolated except for that exponent, which we'll get rid of in a second. So all we need to do right now is type all of this into the calculator. So once you do that, we've got 28 squared plus 26 squared minus 2 times 28 times 26 times cos of 109. So we've got c squared is equal to 1,934.027233. And the last thing we need to do to get rid of that exponent, square root. So square root each side, that cancels out our exponent. So we're left with just little c, or side AB that we're trying to solve for, is equal to about, take the square root of that number, 43.97. We're going to be rounding to the nearest tenth again. So 44, and our units for that side length are miles. So that's law of cosines. Notice last week with law of sines, we were looking for pairs of opposites. So we knew the little letter and the big letter, the side and the angle, both to set that up. For law of cosines today, we're looking for that SAS scenario, so that we have two sides and one angle that's in between those sides. So that's what you're going to be looking at today. So you do have a word problem on the back, so I just want to get started with a diagram there. So it says two airplanes leave an airport, and the angle between their flight paths is 40 degrees. So if we say our airport's at the top here, and we have two planes leaving, forming a 40-degree angle. So we know that angle at the top is 40 degrees. An hour later, one plane has traveled 300 miles. So starting at the airport to where they're at now is 300. Starting at the airport, the other airplane has traveled 200 miles. So we can just say plane B, plane C, and we'll call the airport A since we want our variables labeled as A, B, and C for our formulas. This will make it easier. So we called that the airport. We're just going to change that to A now. So now you have your SAS scenario. You have a diagram just like in number one. You're trying to solve for how far apart the planes are. So you're trying to solve for side A. So that helps you determine which formula to use. Then you just plug in and use the example we went over to help to finish that out. So homework worksheet number 2, law of cosines, odd problems only. 7th period, you can email Mr. Shaw or I. 8th period, Mr. Shaw, Ms. Matos, or myself if you have questions.